Hello everyone, this is an additional video to our StaadPro lecture series. In this video, we are going to see about the analysis of our structure. There are three main methods to analyze a structure. So first one is static analysis, the second one is dynamic analysis, and third one is model analysis. So in this video, we are going to see about static analysis and model analysis. This static analysis is based on displacement and the model analysis is based on frequency and mode shape. So now let's move on to our StaadPro building structure. So this is our building structure. To do our static analysis as normal, let's go to analysis and print, then give the no print option and give add and close. And now let's move on to analyze and run analysis and save. So 0 errors and 2 warnings, and let's go to view output file. Let's go to processing mode, post processing mode. Done. Okay, so now you can see the displacements of our building structure for different directions according to this. So this you can see the all relative displacements, and this you can see the maximum relative displacements. So as this way we can do our static analysis to our building structure. This way is easy to do the static analysis. But now let's move on to the mode analysis. What is this mode analysis? The mathematical method that StaadPro used to calculate the mode shapes is called subspace iteration eigen extraction method. The method involves into matrices. So in this method, we are using two matrices. One is stiffness matrix and other one is mass matrix. In stiffness matrix, while calculating stiffness matrix, we need member length, member properties, and elastic modulus, support conditions. By using these three, support, specification, and property, these three subtabs, we have given data to our structure, and already we have calculated our stiffness matrix. But now we have to calculate mass matrix. To calculate the mass matrix, we need to go to load case definitions, and we will provide whatever the things we will provide. According to that, it will calculate our model calculation. So now let's move on to that, and we'll see how to do the model analysis. So first of all, to calculate the model frequencies and model shapes, model calculation, we have to do the model calculation. So first of all, we'll go to general and load and definition, and then go to load case details and click on add, and we'll put none, and here we'll give mode load. We'll name our load as mode load for our easiness, and we'll click add. Okay, sorry, so no, close. So we'll go to mode, general, load and definition, load case details, and mode load, and now we have to add self weight. We have to add self weight. We will add self weight in x direction, and this is +1, so we'll add this. And again we have to do it to z direction also, so z direction and fact add. So now we have to close. Here the question mark is there, that means we haven't assigned these things up to now, so we have to assign these weights. So we'll click on this and go to select and beams parallel to x, and assign to selected beams, assign. Yes. And now you can see it has turned to green color. That means it has assigned. Now we have to go to save weight Z direction, select beams parallel to Z, and now we have to assign to selected beams, and we have to assign, and yes. So now we have assigned these values. So now we have to go to mode. We have to go to a mode load. Again we have to go to mode load, and we have to click on add. Then now let's add frequency. We'll go to frequency and model calculation, and calculate frequency using the eigen value extraction method. So StaadPro is using eigen value extraction method. So add and close. So we have added that also. Now we'll do the analyzing process. So it is our model analyzing now. So we'll go to analyze and print. So before that we have to save, and we'll go to analyze and print, no print option, and give add, and here we have to close this and go to analysis and do run analysis. Save. 0 errors and 5 warnings. Here we will go to view output file. Done. So you can see here result option is there. So we'll go to result option. In result option you can see Eagen Solution. There's a command called Eagen Solution. You have to select that. In that you can see for 6 different modes they have given the frequencies and the periods and the accuracy. So in here they have, for our further reference, they have given on another one mode to analyze. And so here you can see the frequencies for the first mode, 15.786, like that. You can get the frequency values from here. And also here you can see the mass participation factor in percent. So you can see the participation of modes for different modes. Like for different modes you can see the different participations. So in first mode, if we take the first mode, the participation in X direction, it will be 29.39 and 3.39, like that. But and here you can see the summation of Y direction. Participation of Y direction in modes is 0, all summation, and summation of Z direction is 99.964, and summation from X direction also 99.964. So as that way we can see the in Eagen Solution we can see the frequencies. To further analyze, let's go to post processing. In this post processing you can see dynamic. Here we'll close this, and here dynamic option is there. After going to dynamic option, this here it has shown to first mode, but this is not clear because of the scale. So we'll go to symbol and symbol option, and we'll go to scale, and we'll change our mode scale to 1. So we have changed our mode scale to 1 and click on OK. So this is our mode scale to mode scale. So we'll select for different modes, it will show our vibration. So to have a animation of this, we'll click on animate, and we'll click on mode, and we'll give the range up to 45 to 75. 45 to 75 we'll give. Okay, click on OK. So as this way you can see the animation view. Again let's go to post processing, and this time we'll go to animation, and in animation again we'll go to mode, and we have given the range, and we'll click on apply and see what's there. So you can see animation is happening. So here in this dialog box there's a option called load and results. We'll go to that. In here you can see our mode shapes are available. See, we'll select the first mode shape. in first mode shape, and we'll click on apply. So you can see the rotation and everything in this motion. In while we do like this, you can see everything in animation view from this. So you can change it to model 2 also. Model 2, the frequency is 17.7, so it will be, we have to apply it, so its motion is different. It will be like this, and we'll move on to third one, and we'll apply. Its frequency is 19.6 hertz, so its motion is like this. And we'll move to fourth one. Its frequency is 55.4 hertz. You can see the motion of that like this, and vibration and everything you can see from here. See, this is for our fifth mode. It is 60 hertz, and for the last mode we'll see 62.3 hertz, and apply. We'll click on apply. So this is the way you can and do the analysis of this structure. And when we close this and we'll check, we'll go to post processing again, and you can see for you can see our structures and our for different structures what we have done. So as this way you can do your static analysis, and you can do the you can find the displacement. And also by this way, when you do the model analysis, you can find the frequency and different mode shapes of yours. So this from this video I have completed analyzing process in two ways, that is static analysis and model analysis. I hope you understood everything what I have done and what I have told. So thank you everyone for watching these videos.